let's continue now. Recall that we are looking for the general solution of this differential equation, and we are looking at it in the form where the general solution is going to be the particular solution plus the general solution of the corresponding homogeneous differential equation, which is c1 e to the minus 3t plus c2 t e to the minus 3t. And basically we are now looking for the particular solution of the homogeneous equation, and we are looking at it in the form where y of t is some function u1 times e to the minus 3t. u1 is a function of t plus some other function u2 times t e to the minus 3t. In other words, it is very similar to the general solution of the homogeneous equation. The only different thing is that now the coefficients u1 and u2 are going to be functions of t instead. Okay, and until now we found out that in order to for it to work, in order for this y of t to be a particular solution of the non-homogeneous differential equation, we could look for for u1 and u2 in the following form. So we should look for u1 and u2 functions to be functions that satisfy the following system of differential equations. The following system of algebraic equations actually. So e to the minus 3t times u1 prime plus t e to the minus 3t times u2 prime is 0, and e to the minus 3t prime u1 prime plus t to the minus 3t u2, this is prime, 2 prime is t squared. So notice that this is actually an algebraic system of equations, just usual linear equations with unknowns u1 prime and u2 prime. And let me write down the extended matrix of this system. So the extended matrix of the system, the coefficients are e to the minus 3t, t e to the minus 3t, then e to the minus 3t prime is going to be minus 3 e to the minus 3t. Then t e to the minus 3t prime is going to be, t prime is 1, so it is e to the minus 3t plus t times e to the minus 3t prime, so I will write minus 3t e to the minus 3t. And the right hand side is 0 and t squared. Okay? Well, now we are supposed to solve the system of equations. So this is, again, it's an algebraic system of equations, and we can use Cramer's rule. So now step 3 is going to be applying Cramer's rule. So let me write it now. We have step 3, and we are going to apply Cramer's rule. So according to Cramer's rule, then a solution can be constructed as a combination of determinants. So first, determinant A is going to be determinant of this matrix of the Wronskian of the system, e to the minus 3t. So we just take the coefficients, t e to the minus 3t, then their derivatives, minus 3 e to the minus 3t, and e to the minus 3t minus 3t e to the minus 3t. Okay, so let's compute this determinant. E to the minus 3t can be taken out from both the first row and the second row, and we'll get e to the minus 6t times. Then on one diagonal we have 1 times 1 minus 3t, on the other plus 3t, so it's just 1. So that's it. Okay. Then in order to apply Cramer's rule, we need to compute determinants of 2 more matrices. A1 is the matrix where we take the matrix of coefficients and we replace the first column with the free, so with the right hand side of the system of linear equations, right? So we need to replace the first column with 0 and t squared, and the second column remains the same, so t to the minus 3t, and here we have e to the minus 3t minus 3t to the minus 3t. Okay, that's a simple determinant, so it is minus t cubed e to the minus 3t. So then determinant of A2, according to Cramer's rule, we need to replace the second column of the matrix, of the coefficient matrix, with the right hand side. So we keep the first column, just e to the minus 3t minus 3 e to the minus 3t, and here we insert 0 and t squared. And here we get t squared times the minus 3t. Okay, so that's, and according to Cramer's rule, the unknowns, recall the unknowns are u1 prime, is going to be determinant A divided by determinant A1. Sorry, determinant A1 divided by determinant A. So we always divide by determinant A, because it has to be non-zero. Right? So determinant A1 is minus t cubed times e to the minus 3t divided by e to the minus 6t. We will get minus t cubed e to the 3t. And then, because of the similar reason, u2 prime is going to be equal to determinant A2 divided by determinant A from Cramer's rule, and this is going to be t squared times e to the 3t. So that's the end of step 3. So let me erase this. Yeah, so I'm using it as a whiteboard actually. Yeah. So recall that so far we have obtained u1 prime and u2 prime, and the motivation was that in order for the combination u1 times e to the minus 3t plus u2 times t e to the minus 3t to be a particular solution of the non-homogeneous equation, u1 prime and u2 prime must satisfy a certain system of equations, and by solving the system we kind of are almost done. But the problem is that this is u1 prime and u2 prime instead of u1 and u2, so which means that the fourth step has to be integration, right? So we have found u1 prime, so which means that u1 itself is going to be the integral of this of minus t cubed e to the minus 3t dt. Well, so here we have a problem. I mean, it is doable, but it is very, very long, so in order to solve it, you will have to integrate by parts 3 times. But since I'm not teaching calculus, this is differential equations, I'm sure that you know how to integrate by parts, which means that I don't want even to test you on integration by parts. Right? So whenever you say need to solve a similar question at home, you can simply do it in Wolfram Alpha. Right? So, and I did it myself. So from Wolfram Alpha, I know that the answer here is wow, it is pretty complicated. Minus 9t cubed minus 9t squared plus 6t minus 2 everything over 27 and times e to the 3t. That's u1. So u2 is in the same fashion it is going to be the integral of t squared e to the 3t dt, and again from Wolfram Alpha I know that this is 9t squared minus 6t plus 2 divided by also 27 e to the 3t. Well, that's basically it. Essentially we are done, so the only remaining thing is to put everything together. Right, so that's as we have step 5. So step 5 is putting everything together. Right, so first we need to calculate the particular solution of the corresponding of the non-homogeneous equation, and the particular solution, recall that it is going to be u1 times e to the minus 3t plus u2 times t e to the minus 3t. So let me compute it. Okay, so notice that e to the minus 3t and e to the 3t here and here are going to very nicely cancel out. So then I'm going to get minus 9t cubed minus 9t squared plus 6t minus 2 over 27. That's the first summand, plus u2 times t. So times t means that I need to increase the power of t, so I'm going to have 9, instead of 9t squared, I'm going to have 9t cubed minus 6t squared plus 2t over 27. Okay, so minus 9t cubed plus 9t cubed cancel out. Then I have minus and minus is going to give me 9t squared minus 6t squared, which is 3t squared. Then minus 6t plus 2t minus 4t, and minus 2 plus 2 over 27. Alright, so let me erase this. So recall that this is a particular solution of the non-homogeneous equation. So basically we are almost there. So the particular solution of the non-homogeneous equation is 3t squared minus 4t plus 2 over 27. So the solution that we got after so much pain is this one. But then it means that the final answer, which is the general solution, the final answer is going to be this particular solution, 3t squared minus 4t plus 2 over 27 plus some combination of c1 e to the minus 3t plus c2 t e to the minus 3t. So this is the general solution of the non-homogeneous equation, and that's the final answer. Okay, so here is the final answer typed again, so let me review it very quickly. So first we look for the answer in this form. So it is a combination of the linearly independent solutions of the homogeneous equation with coefficients that are functions of t. Then, after some tricks, applying Cramer's rule and applying these clever tricks, we found that the derivatives of the unknown functions, but then we can get the unknown functions then themselves back by integration, and then finally we can put everything together, and that's going to be our final answer.